Today we're going to learn about medians of a triangle. A median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. A triangle's three medians are always concurrent. So if we take a look at this model here, based on the description that I just read, it says a median is a segment whose endpoints are a vertex and a midpoint of the opposite side. So let's take a look at D as our vertex. The median connects to the midpoint of the opposite side. So point J is the midpoint of segment FE. That is what a median is. So again, vertex and midpoint of opposite side. The medians theorem states that the medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. So if we look at this model, let's take a look at the median that I traced over. And I'm going to highlight this in green as well. So this theorem states that a point is 2/3 the distance from each vertex to the midpoint of the opposite side. That means this point is 2/3 the distance, and this point is 1/3 the distance of the total line. So whatever the full line length is, if this segment is 2/3, obviously to get to the full segment length, this segment would have to be 1/3. So if I write out a statement about that line, I can say that segment DC is 2/3 the length of the entire segment DJ. So 2/3 times DJ will give you the length of this part of the line. 1/3 times DJ will give you the length of this part of the line. If we look at another line, if we look at point F as our vertex and H as our midpoint, this right here is also called a median. We have the full length of the median. However, this part of the line is 2/3. This part of the line is 1/3 of the total length. So I could say that segment FC is 2/3 the length of the total line FH. Or I could say that CH is 1/3 the length of the total line. Point E and point G. So we know the longer segment, or the segment coming from point E, is going to be 2/3, and the smaller segment is 1/3. So segment EC is 2/3 the length of segment EG, or the total length. Or you could say CG is 1/3 the length of the entire segment. So in a triangle, the point of concurrency of the medians is the centroid of a triangle. This is the point called the center of gravity because it is the point where a triangular shape will balance. For any triangle, the centroid is always inside of the triangle. So imagine if you could cut a triangle out on a piece of paper and you could balance it perfectly on your pencil. There's only one point on the triangle where you could balance it because of the weight of all the sides. So wherever that one point is for balancing, that is called the centroid. And it's actually always going to be the point determined from all of your medians intersecting. If we look at the first example, I'm going to take a moment and I'm going to trace over the medians. I'm going to start with point X. Point X connects to the midpoint of point C. So knowing that C is a midpoint, I know I have two congruent segments on each side. Next, I'm going to look at point Y as a vertex connecting to the midpoint of B. And lastly, we have Z as our vertex connecting to the midpoint of D. Now starting with number 1, it says in triangle XYZ, A is the centroid, meaning this point is the center that you could balance the triangle perfectly on your pencil. If DZ is equal to 12, then we're looking to find the length of ZA and AD. So DZ is this entire length here, and I'm going to label it. I know there's a lot of lines on the graph, but I'm going to label this entire length as 12. Recall that the portion coming from the vertex to the centroid is going to be 2/3 of the total length, and the shorter section is 1/3. So to find the length of ZA, ZA is this length here, it's 2/3 of the total length. We are going to multiply the fraction of 2/3 by the total length of 12. This is equal to 24 over 3, or we know that ZA is equal to 8. Next, we're looking for AD, and AD is 1/3 the length of the total segment. So 1/3 times 12, which is the same thing as 12 divided by 3. We know that segment AD is equal to 4. Number 2 states that AB is 6, and we're looking to find BY and AY. So our statement is telling us that this segment, AB, is 6, and we're looking to find the entire length and also this shorter length. So if 6 is 1/3, you could technically double that number to give you the 2/3 length. Or you could find the length of the entire figure or the entire segment. There's multiple ways to go about this. I think in my head I would recognize if 1/3 was 6, then 2/3 would obviously be 6 plus 6, which is 12. But again, you can do it whichever way you want. Let's see, so I'm going to write down what I just stated. So if I know that AY is equal to AB plus AB, I know that AY is equal to 6 plus 6, and I know that AY is equal to 12. Now, if I know that this segment is 12, I know that the entire segment, which is YB, I stated it as BY, BY is equal to my segments added up, which is segment AY plus segment AB. That's equal to 12 plus 6. BY is equal to 18. Okay, what you could have done was you could have started with knowing that BA, I'm going to write this over here, BA is 1/3 the length of the total segment, BY. I just wrote that wrong. Okay, and then from there I could fill in what I know. I know that BA is 6. 6 is equal to 1/3 times BY. Multiply both sides by 3. And I know that 18 is equal to BY. Same answer as what we already got, another way of solving it. So however you go about that is fine. And lastly, number 3. Number 3 states that if AC is equal to 3, then we need to find CX and AX. So this is stating that AC, this shorter length here, is 3. And we're going to go about this the same way. At this point, I think you can figure some of them out in your head. So I know that AX is going to be equal to 3 plus 3. Therefore, AX is equal to 6. I know that CX is the total length, so CX is the same thing as if we added up 6 plus 3, and we know that CX is equal to 9. Once again, we could have solved this differently. We could have said that CA is equal to 1/3 of CX. We could have substituted in the fact that CA is 3. 3 times 1/3 times CX. Multiply both sides by 3. 3 times 3 is 9. 9 is equal to CX. Same answer, different way of solving. So whether you want to use what you know and use basic math to just figure it out, which is what I did here, or you want to substitute into the formula, which is what I did there, completely up to you. You'll always end up with the same answer. Okay, for the next example, I'm going to go ahead and do this and you can follow along. I'm not going to talk through it. It's very similar to the last example. So you'll see all my work done out throughout this problem. Please let me know if you have any questions.